let's take a look at this side of the paper, okay? Let's take a look at this side. So far what we've been doing is we've been graphing one linear inequality. We graph the line, right? We decide if it's dotted or solid, and then we shade one side or the other, right? We've been doing that so far this week. Now we need to look at a system of inequalities. So 2 of them. We have to do this twice. So let's do this first one together. These are both in slope-intercept form, which makes it a lot simpler. That first inequality, what is my y-intercept and what is my slope?
-2 and then -5.
Yeah, good. My y-intercept is -2. My slope is -5, which is like -5 over 1. That means I go down 1 or down 5 over 1. So I start at -2. I go down to -2 on my y-axis, and then I try and go down 5 and over 1, but I run out of graph, right? So what do I do? Yeah, I can go up 5 and then to the left 1. Good. That's really good, you guys. Bless you. And okay, I have a less than or equal to. So does that mean I use a solid line or a dotted line? Solid line. So I just connect those points with a solid line. And then what's my final step when I'm graphing an inequality like this? Yeah, I got to figure out if, like, I plug in 0, 0 to determine if I shade on the right or on the left, over here or over here. So I'm taking 0, 0, and I'm going to plug it into the inequality and see if it's true or false. So I take that inequality, y is less than or equal to -5x minus 2. And I'm plugging in 0 for x and 0 for y. And I'm asking the question, is this true or is this false? Is 0 less than -5 times 0 minus 2? What's -5 times 0? And 0 minus 2 is? Is 0 less than -2? No, it's false. So what does that mean for my shading?
Shade the side that doesn't have 0.
Exactly. I have to shade the side that does not include 0, 0. So that's over here. Okay, we okay on that? Now let's do the other one. We'll do it in green. So this one, y is less than -x plus 2. What's my slope?
-1 over 1x.
Excellent. Just -1 over 1, yeah. So down 1 over 1. And what's my y-intercept?
2.
Perfect. So I start at 2, and then I go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, all the way. And I can even go back up and get the full shape of my line. And for this one, it's a less than. So what do I do for less than or greater than? Dotted line. So I make a dotted line in between these points. Okay, and then last step for that, find if it's true or false. Plug in 0, 0 and see if it works. So I plug that into y is less than -x plus 2. Plug in 0 for y and 0 for x. So I end up with 0 is less than -0, which is just 0, plus 2. What's 0 plus 2? 2. Is 0 less than 2?
Yes.
Yeah, it is, right? That's true. So what does that mean for shading?
Shade the side with 0.
Exactly. Shade the side with 0, 0. So it's going to be like underneath. So then where do you think the solution is?
meet?
Yeah, it's where they meet. Not just the one single point where they meet, but actually this whole section here. All of these points in like the yellow section where the purple and the green lines were, all of those are solutions to this system. Okay? Does that sort of make sense? Why not? What are you confused? Because you just carried the weight of the whole class in graphing this, Daniel. So I know the graphing part makes sense. So what part is confusing?
It's just confusing.
Is it like the solution part?
Yeah.
Yeah. So it's just where they intersect or where they overlap, right? Where it's purple and it's green, right? There's this little sliver right here that's just purple. There's this chunk that's just green. This part that I highlighted in yellow is where it's purple and green. Okay? I'm going to do, pardon? Because I have to just look where they overlap. And this part isn't purple, right? This part isn't a solution to the purple line. It's only a solution to the green line.
How do you write the solution?
So you don't write the solution, you just show the graph. Okay? Right? Like when we did equations, you had to tell me this point, right? -1, 3. You don't have to do that for this. All you got to do is just show the graph. Okay? And on the quiz today, you do not even have to draw it. All I'm going to do is I'm going to give you a system of inequalities and then 4 options. You just choose one option. It's just a multiple choice. Okay, so I just give you the inequalities and you just got to pick which graph represents those inequalities. Okay? Does that make sense? Yeah? Let's do number 2 together as well, okay? Number 2 as well. So the top equation, right? Slope-intercept form, just got to pull out what's my slope, what's my y-intercept.
4 over 1 x.
Or not, it's not a 1.
-4 over 3.
That's my slope.
Number 3.
Yeah, sorry. I said number 2, didn't I? I meant number 3. My bad.
Y and x. Or -1.
Good job. Okay, so I go down to -1 on the y-axis. -4 over 3 of a slope is my slope. That means I go down 4 over 3. Down 4 over 3. And I could go up 4 over 3 as well.
If you have like an less than or equal to or like that, and it's not, it doesn't have a bar underneath it, it's not equal to actually, do you have to put open circles?
No, just a dotted line. That's all. Yep. The open circle is just for the single variable. That's a good question. So, but for this one, what do I do? Solid or dotted?
Solid.
Solid, right? Because it has that equals there. Solid line. And then what do I do to check what side to shade? Plug in 0, 0. So if I plug in 0, 0 to that inequality, just write it. 0 is less than or equal to -4 over 3 times 0. Oops, I did orange. -1. What's -4 over 3 times 0? 0. What's 0 minus 1? -1. So this says 0 is less than or equal to -1. Is that true or is that false? False. So that means I shade the side that does or does not contain 0? Does not contain 0. So this whole side. Okay. And then I'll do pink instead. So let's look at the second inequality now. What's the slope? Just -1 over 3, yeah. So I go down 1. over 3. And my y-intercept is 2. So I go up to 2 on my y-axis, and then I count down 1 and over 3. Can't really keep going, but I can go backwards. I go up 1 over 3 like that. And this one, solid or dotted? Dotted. Dotted, 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 dotted. Do, 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 do. I have my line. Now what do I do? Yes. So I'm going to plug in 0 for y and 0 for x and see if it's true or false. What's negative 1/3 times 0? 0 plus 2 is? So is 0 less than 2? It is. So it's true. So what does that mean? Shade the side with the 0. Right? So again, when I draw 2 lines like that, right? Line, line. There's like 4 little sections. 1, 2, 3, 4. Only one of those 4 sections is the solution. So it's just for this purple and the pink intersect. Does that make sense? Okay. So what I'm going to do for numbers 2 and 4. Give me my numbers on this one. I'm going to show you examples of what they can be, and all you got to do is just match them up to what I'm going to put on the board. You don't actually have to draw them all the way out if you don't want to. And this will be a hint to solving the riddle at the bottom of the paper. There's a riddle. The riddle? No. Okay. So far we did numbers 1 and 3, right? Which letter is number 1? Which letter is number 1? Huh? M. And they cross at negative 1, 3, right? I have 1 solid line, 1 dotted line. Okay, that's my shaded area. Yeah.
Is this like, so is there gonna be like a, like how are we gonna be able to figure out what it is? Like, is it comparing to something?
So I'm giving you the inequalities. So let's look at, so hold on. I'll get there, just 1 second. So number 1 was M, and I know that because when I graphed it, I saw that those 2 lines intersected at negative 1, 3. I also saw in number 1 that I have a solid line and a dotted line. Solid line, dotted line, right? My solid line had a y-intercept of negative 2. My dotted line has a y-intercept of positive 2, right? That's how I know that that's that. Then what about number 3? What letter is number 3?
I.
Yeah, I. And how did you know that? Okay. How else did someone else know it?
Because at the end of it, the top is where the shaded part is before the dotted line comes in.
Yeah, there's this little section up here. That's what you look for? Mm-hmm. Yeah, that's good. That's good. And again, in number 3, I have 1 solid, 1 dotted line. The solid line has a y-intercept of negative 1. The dotted line has a y-intercept of positive 2. So those are kind of the giveaways, you know? So now let's look at 2 and 4. What letter is 2? Why? They're both dotted, but so is I, or so is T and E. They're both dotted. So that's not enough. What else do I know? Huh? The y-intercept. So what's the y-intercepts on number 2? Negative 3 and 3. Right down here, I don't have a y-intercept at negative 3 and 3. Right? Does that make sense? How we can kind of use that. So E was 2 and T was 4.
So is it just gonna be like a graph just like this? Like, is it?
So it's a little different than this. I'm going to give you one system of inequalities.
Okay.
And then you pick one graph. So in your system of inequalities, look for y-intercept, look for slope. Look at your graphs to see which one matches up. Okay? And then you can kind of think about shading as well. But that's just one question. Just a small part of your quiz.
Do you shade twice?
Yeah. Yeah. Yeah, shade twice and see where they overlap. Did anybody figure out the riddle? Yes, the hint is time, but how do I, if I add 6 to 11, huh? Yeah, yeah. If I add 6 hours to 11, then I get 5 p.m. So 11 plus 6 is 5. Silly riddle. Okay. What else did I want to do? I'm going to tell you what else we've got on the quiz and kind of get some more notes down. So on the other side of this paper, you've got that quick note section. Let's do an elimination problem together. Elimination. Yeah. Okay. Elimination. You guys look at my posters up here? Did that during today. Nice. Look at your elimination poster. What's the goal of elimination? Yeah, to eliminate one variable. So if I look at the coefficients of my x's, what are they? -3 and 3. What are the coefficients of y? Which variable am I going to be able to eliminate easier? Yeah, the -3 and 3, the x's. Good. So do I have to add these two numbers together or subtract? Add, that's right. I should have done this on here. Hold on. Go back. Whiteboard. -3x plus, can you remind me what it is? -3x plus 7y? And then +3x minus 4y equals -1, right? So we decided, right, my x's are going to be able to cancel out. Get rid of all the other stuff. The x's are going to cancel out if I add these two equations together, right? Those cancel. What's 7y plus -4y? 3y. And 13 plus -1? 12. How do I solve for y then? Divide by 3, divide by 3. So y equals what? 4. And then what do I do now? Because that's only half of my answer. Plug in 4 for y. Does it matter if I plug it in for this y or this y? Nope. You can do either one. I'll use the bottom equation, -4 times 4 equals -1. What do I do to solve this? What should my first step be? Which is? 16. 4 times 4. Oh, you did the top one. Huh? Yep. Yeah. Yeah. So now I have 3x minus 16 equals -1. There you go. Add 16. These cancel. Add 3x over here equals 15, right? -1 plus 16 is 15. And now? Perfect. and I write my answer as an ordered pair. Okay? Elimination, that's the first question on the quiz. And then I'm going to give you something like this. And I'll give you a number line. And I'm going to ask you to graph it. How do I graph something like this?
Dot on 7.
Open or closed? Closed. And arrow to the left. Yeah. X is less than or equal to 7. So yeah. And the variable is first, so I go in the same direction as the inequality. You guys okay? Okay, so one like this, where I give you the inequality and you need to graph. And then I'm also going to give you another one where I give you the graph. I give you the graph, and you have to write the inequality. X is greater than 16, exactly, right? I always start by just, oh no, I don't want to do that. But let me just speak through this really, really quick. I just always start with like, okay, I have a variable, and I always want to put my variable on the left, and then the number is just where the circle is, right? So 16. And since I put the variable on the left, my inequality goes in the same direction as my arrow, as my line. So X is greater than 16. Okay, so you got an elimination problem, you got a problem like this, you got a problem like that, and you have that multiple choice question. And that's it. That's the whole quiz. It's really quite simple. Any questions before we start? Anything you want me to go over? Yeah.
Why is it so easy?
Because no, I just want to, give you a nice underhand pitch so you can hit one out of the park. That's what I want. That's what I want to happen.
I was in so
Yeah. And you have a test next week, so which is a little bit, it's going to be harder than this. So just want to give you something to kind of pad your grade a little bit too.
Can we start now?
Yes. Get dividers up, pencils out. You can use this paper. Does anybody else tell me this stapler? And when you're done.
You gave me an insecurity. I'm so sorry about that. I did that for everybody. Now I have a insecurity just for me. I was pretty happy in 6th grade. I honestly was we're in band together. No, because when we were in the also COVID, the first thing I said,
Micah, if you want a harder quiz, I have a harder quiz.
sorry.
Hurt my grade if I fail it? Okay, then I'll take it.
Shut up, Ryan.
If you come in with my grade.
I was devious. I am.
No more talking. And you can just turn it into the inbox when you're done. And please also turn in that Thursday paper as well. They'll give you participation points for doing the graphs. And if you do any of this, check your understanding, so I'll count that as extra credit. Cool.
So we add them. What's -4 plus? Then you put it in. Yeah. -4 plus. One.
And then again, you can do those check your understanding questions for some extra credit classwork, or if you have any missing work, now's a good time to do that.